Okay, let's start. So, show that differentiation of blah 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 is equals to 1 minus tangent x. So let's do our differentiation first. So this one is not applicable for normal acad because this is logarithm. Okay, they don't learn logarithm. So to differentiate ln, okay, so I'm going to write out differentiate ln e to the power of x cosine x. Okay, we know that differentiate ln is 1 over this. Okay, so it's 1 over e to the power of x cosine x. Multiply by, I have to differentiate the inside. But my differentiate of the inside is a bit complex. Why? Because I have to apply product rule. So in such a situation, what do I do? For me, I always like to do it separately. So I do separately for my differentiation of ex cosine x. So I have to apply product rule. Okay? So I will write it, keep left, differentiate right. Differentiate cosine, give you minus sign. Minus sine x. Plus, keep my right hand side, which is cosine x. Differentiate e to the power of x. So differentiate exponential is keep the same. Differentiate the power, give me 1. So actually it's just 1. So if I want to simplify this, I can take out my common factor, e to the power of x. So I have minus sine x plus cosine x, okay? So now this is my differentiation of this. So I'm going to plug this and put it here. Because when I differentiate ln, I need to have 1 over this multiply by differentiate inside. So my differentiate inside is here. So I'm going to put it here. Ex minus sine x plus cosine x over 1. And you can see that we can actually cancel the e to the power of x. Cancel the e to the power of x. So cancel the e to the power of x. I left with this over this. So I left with minus sine x plus cosine x over cosine x. And because my denominator is only 1 term, so I can split these two. So it becomes minus sine x over cosine x plus cosine x over cosine x. So this one become 1 and this one become tangent x. So I have my minus tangent x plus 1, which is this one. Okay, you can rearrange, no problem, equals to the right hand side. Shown. Right? So 3 marks question. Okay, this is tricky. Why? As in it's like you have to differentiate the inside, a bit complex. So we can do it separately, then we plug it back here, no problem. Okay, so this part is called what? I call it the reverse. What I mean by reverse is integration doesn't have many rules. So a lot of times is they will make use of the differentiation to solve the integration. Okay, so you can say that using part 1, okay, they ask you to integrate tangent x. There's no way we can integrate tangent x immediately, okay, because we can only integrate sine, integrate cosine, integrate secant square, but we cannot integrate tangent x. So we're going to make use of this one. So after this part, I always ask my students to write the reverse. See here, if I differentiate this, I get this. Do you agree that I integrate this, I will get this? So I will rewrite as, so that means when I integrate 1 minus tangent x, I should get back ln ex cosine x. Then don't forget to put a plus c because there's no limits here. Okay, so in this case, your objective is to solve integration of tangent x. Do you see that it's actually here? So your task is to make this the subject. So now we can split these two. So it becomes integrate 1 dx minus integrate tangent x dx is equals to ln ex cosine x plus c. Right? So see here, my task is positive integrate tangent. Here is minus. So what I'm going to do is, okay, before I do that, let me integrate this first. Integrate 1 dx is just x. So this is x minus integrate tangent x dx equals to ln ex cosine x plus c. So I'm going to bring this to the right hand side and bring this to the left hand side. So therefore, integration of tangent x dx will be equals to x minus ln ex cosine x plus c. You see that? So this is making use of the differentiation to solve the integration. So I always ask my student to write this. You always write this reverse thing. Means when I integrate this, I get back this. So I write it in this way. Integrate this, get this one. Then all you need to do is look at the subject. They ask me to integrate tangent. So I see, oh, okay, actually it's part of it here. So we split it. So usually it will contain more than one term. One of the term is you can integrate as per normal. One of the term is the subject that they ask you to find. So I integrate this as per normal. So it becomes x. Okay. I understand that students say, this one also got plus c, how? It doesn't matter as long as I have one side which is plus c, because c is just a constant. So if I plus c here, plus d here, but eventually it's just one constant. So I only need to write one time. Okay, so because this is negative and this is positive, so that's why I bring this to this side and bring this over this side. That's why it's x minus this. So this is the answer for this part. Okay, next. They say, hence, show. Okay, so we already have this one. Okay, we know it's this answer. So we need to sub in the limits. Okay, this is a little tricky. So be careful of how I manipulate. So it means that I want to put this. I can write here, integrate pi over 3, 0 tangent x dx is equals to the limits put here. This is the x minus ln ex cosine x, limit pi over 3 and 0. So you need to sub in. Okay. So after that, see here. So we're going to start pi over 3 first. So replace all the x with pi over 3. So this is pi over 3 minus ln e pi over 3 cosine pi over 3. Okay, for me is I sub in this. Okay, then we are supposed to minus sub in 0. So you see I make use of square bracket. So it will be meter. 0 minus ln e to the power of 0 cosine 0, close it. Okay, so now let's work it out. Cosine pi over 3 is half. So I will have pi over 3 minus ln. Do you see that this is multiply? If it's multiply, actually I can split it. So it becomes, but you have to be careful that you got to put the bracket. So it's actually e pi over 3 plus ln cosine pi over 3. Okay, e to the power of 0 is 1. Cosine 0 is also 1. So this actually becomes ln 1. And ln 1 gives us 0. 0 minus 0 is just 0. Okay, so this behind part is just minus 0. Okay? Okay, now over here. So now see, pi over 3 minus, power law tells me that I can bring this down. And ln e is 1. So this is pi over 3. Just now we will say that this one is half. So this is actually ln half. So I don't care about the 0 already. Okay, so now over here I have pi over 3 minus pi over 3 minus ln this. So this one no more 0, I left with this. But how am I going to prove that this is ln 2? Okay, how am I going to prove that this is ln 2? So see how I do. Do you agree that half is actually 2 to the power of negative 1? Okay, so it's 2 to the power of negative 1. So power bring down, so it's minus. Okay, I have a minus here. So it will be minus minus, so it become positive ln 2. Understand? So it's equals to ln 2, which is equals to the right hand side. Shown. So this part tricky is you have to be very careful with the, you have to put bracket here. Because this one, if I'm going to split it up, is plus. But this is a minus, so I got to put bracket. With the bracket, this will become minus eventually. And then after that, I need to know that half is actually 2 to the power of negative 1. Power law, negative 1 times negative 1, that's why it becomes positive, okay? Okay? Hello? Okay? So this is a little tricky. So you need to know how to manipulate and be careful with your bracket. So this is for this question. All good. Any question for this part? If not, I move on to the next one. Okay, let's go. This one. Okay, we are supposed to find the coordinates first, and then before we can find the area under the curve. Okay. So in this question, they ask to find, eventually you need to find area of this one. But for now, they ask me to find the coordinate of A, and then find the equation of the line AB. So now let's read the question and see what we have. First, this is the curve. Okay, they tell us that this line AB is the tangent. Okay, you see the word tangent, you know that you want to link to dy dx. Okay, the line AB is tangent to the curve at point A. And they tell us that the gradient of the tangent at A is 3 over 2. So this information tells us that dy dx is equals to 3 over 2 at the A, at point A, which we don't know what is A yet. So we put it here first. Okay, this is one information that we have. You need to find A. So actually what we need to do is, I need to do dy dx first. I have my y here. So let's do our dy dx. Okay, y is equals to 3x plus 4. Square root is to the power of half. You need to change this to half. Then you can apply chain rule to differentiate this. Okay, so for those who are very weak in your differentiation, can go to my YouTube channel. Okay, I have a video on the differentiation of the 5 rules. So the very basic of your differentiation must be very good, and go and follow the videos and the questions to master your differentiation skill. So power bring down, so it will be half, copy. Power minus 1 will be minus half. Multiply by differentiate the inside, which is 3. So because this is minus half, I'm going to it will be at the denominator. So 3 over 2. So I have 3 over 2 square root 3x plus 4. Okay, so this is my dy dx. So dy dx is equal to 3 over 2 at A. So we can actually find out what is my x coordinate for A by subbing dy dx is equals to 3 over 2. So what I'm going to do is, okay, I'll let 3 over 2 square root, this one is 2. Equals to 3 over 2. And because this, yes, I'm using chain rule. Power bring down, keep the inside, power minus 1. Half minus 1 is negative half. Okay, then after that, multiply by differentiate the inside, which is 3. Okay, I'm using chain rule. Okay, so this one equals to 3 over 2. So just nice, the numerator is 3. So I can straight away say that 2 square root 3x plus 4 is equals to 2. So square root 3x plus 4, 2 divided by 2, which is 1. Square both sides, square 1 is still 1. So I end up having 3x plus 4 equals to 1. So I have 3x equals to minus 3, x equals to negative 1. So now I know my A coordinate is, the x coordinate is minus 1. Don't forget to find our y. So you need to sub the x into the original y. Sub into the original y. So my original y, I can use this, no issue. So y is equals to 3x plus 4 to the power of half. And when you press the calculator, you get 1. So therefore, you will know that A is minus 1, 1. So we resolve this part, the coordinate of A. Agree? We resolve this part. We resolve this. Done. Next, they ask to find the equation of the line AB. So they tell us that this is the equation of the tangent. So to find equation of tangent, so I'm going to continue here. To find equation of the tangent line is y equals to mx plus c. So do we have the gradient of this tangent line? Yes, we do. They already give it to us over here. Agree? So my equation of tangent line, will be y equals to mx plus c. My m is here, so 3 over 2x plus c. So now to find c, I need to sub a point which is on the line, and the only point I have is the a, which I already found it just now, which is negative 1, 1. So we will just sub negative 1, 1. So y is here, x is here, 1 equals to 3 over 2 minus 1 plus c. So we will have c is equals to 1 plus 3 over 2, which is 5 over 2. Therefore, equation of the tension, equation of the line AB will be y equals to 3 over 2x plus 5 over 2. Done. Right? So, this is how you solve this. 5 marks, huh? Okay, so now I'm going to update the diagram with whatever I have found now. Find now. So minus 1 and 1. So go to the diagram. We can always put here minus 1 and 1. So we will know that later we want to find area of under the curve now. So we know we need all these x coordinate. So you will draw a vertical line down. This is to remind myself that this is minus 1. This is minus 1. Okay? And if you want this one also can. This is to remind you this is 1. Minus 1, 1. We will need this later. Okay? Okay, so now let's move on to the next part. Now, they ask us to find the coordinate B and C. So now let's go back to the graph and let's see. B and C. Let's take a look at B. B is on the line, which just now we already found. The equation of the line is here. Okay? And B cuts the x-axis. And at B, we know that our y coordinate is 0. So all I need to do is sub y equals to 0 into this one. Agree? So we will go to here. We will say sub y equals to 0 into y equals to 3 over 2x plus 5 over 2. So you will have 0 equals to 3 over 2 x plus 5 over 2. 3 over 2x will be equals to minus 5 over 2. So my x is equals to minus 5 over 3. All I did was minus 5 over 2 divided by 3 over 2. So now I have my b. So therefore, b is minus 5 over 3, 0. So we solve b. So again, update the diagram. So here, this is minus 5 over 3. Next, you want to find coordinate C. So let's go back to the diagram and let's take a look at where's C. So C over is here. See, C is on the curve. And C is also on the x-axis. So it means I simply just need to sub y equals to 0 on this curve equation, and we can find the corresponding x. So what I'm going to do is I'm going to sub y equals to 0 into y equals to square root 3x plus 4. Okay, so you need to be very clear whether the point is on the line or the point is on the curve, and then you sub accordingly. So this one will become 0 equals to square root 3x plus 4. Square both sides. Square 0 is still 0. So I have 3x plus 4 equals to 0. X equals to minus 4 over 3. And now I know my C is minus 4 over 3, comma 0. So again, go back to my diagram. Go and update. This C is negative 4 over 3. Okay? So we have all the critical points. So now you see, they asked me to find the area of the shaded region. So now let's take a look at the diagram. Okay? Area of the shaded region. Okay, so Okay, just now I draw this line, right? Okay, you see, this A, B, here, up to here. Do you see that this is a triangle? This is a triangle, It's a triangle. So a lot of time area of the shaded, right? You have to understand that when we integrate an area under the curve, what you are trying to find. So you see, if I'm going to integrate this, Okay, I sweep from -1 to this -4/3. I'm trying to find this unshaded one, which is not the one that I want. But I need that, okay, because I need the triangle, area of the triangle. I minus that, I can get the shaded area that I want. You understand? Okay, that's why I always ask my student, okay, x coordinate, you must always draw the vertical line down so you can visualize. So in this case, area of shaded ABC is equals to the triangle minus integration of the 3x plus 4, and I'm going to sweep from -1 to -4/3. Okay, you always sweep from big to small, big to small, big number to small number. Okay, so it will be -1 to -4/3. Okay. Okay, now let's take a look at the triangle. What's the base and the height of my triangle? The triangle, I'm going to use here. The triangle is from here to here. So how am I going to find this length? You take the big minus small. -1 minus -5/3, you get 2/3. So this is 2/3. Okay, this one. What I did was I take -1 minus 5/3, so I get 2/3. How about the height? That is why, you see, I put here 1. So the height is actually just 1 unit. So the triangle is simply just half multiplied by 2/3 and multiplied by 1. So this is the area of my triangle. So now the tough part is we have to integrate this one. So integration is, this one very straightforward, it's just power plus 1. So see how I integrate. Power plus 1. So half plus 1 give me 3/2. So it is 3/2 over the new power. So it is 3/2. And don't forget to differentiate the inside, which is a 3. Put it at the denominator. So it's here. So then now this one is to put the limit. I'm supposed to sub -1 as well as -4/3. So this has a lot of fractions and negative value. So you need to be very, very careful when you sub. Okay? So I'm going to extend a little bit because later I got no space. So equals, this one in front is very straightforward. It's just 1/3. So you need to super focus on doing this part. So let's simplify this inside first. I will have, see 3/2 times 3 is 9/2. When we have 1 divided by 9/2 is actually 2/9. So this is actually 2/9, 3x plus 4 to the power of 3/2. And I'm going to sub in -1 and -4/3. So now we are ready to sub in. You have to be super careful because there's a lot of negative. So I'm going to make use of my round bracket. I'm going to use curly bracket. So let's sub in. So I have 2/9, 3 minus 1 plus 4 to the power of 3/2 minus 2/9, 3 minus 4/3 plus 4, 3/2. Okay, 1/3 minus, see 3 times -1, -3. -3 plus 4 is 1. 1 to the power of anything is 1. So actually this first one is actually 2/9 times 1. So this is actually 2/9 times 1. Let's put my curly bracket first. Because this is subtraction, so I need to be very careful with my bracket. So now let's take a look at this part. 3 multiplied by -4/3 is actually -4. -4 plus 4 is 0. 0 to the power of anything is 0. 0 times 2/9 is 0. So actually the back side is just 0. So it becomes -0. So in the end, I'll just get 1/3 minus 2/9. And my answer is just 1/9 unit square. Okay. Sam, take note. This one the answer is wrong. This is 1/9. I have already checked. Okay, this is 1 over 9 unit square. Okay, so this is how you do this question. Okay, this question is just have to be very careful with all the negative and bracket. Okay, now let's go to the next question. Partial fraction. So a lot of times students wonder when do we use partial fraction. Of course, sometimes they might not even come out an individual question on partial fraction, but they come out in the integration part. Why? Because they ask you to do partial fraction at the first part, then after that they ask you to make use of your partial fraction to do the integration. So here is one sample, one example. So it is also a good time for you to recap how to do partial fraction. So every time partial fraction, the first thing you need to check is whether is it a improper fraction or not. Okay? So let's check at the degree. Look at the numerator. My highest degree is 2. The denominator highest degree is also 2. Whenever the numerator degree is the same or more than the denominator, it is considered a improper fraction. So if it's an improper fraction, you need to do long division to make it into a mixed, so-called mixed number. But in this case, it's in terms of algebra. So we need to do our long division over here. So this one will be 8x squared minus x. I'm supposed to divide it by, okay, you see, when I divide, do you see that the denominator, there's a missing term of x? So when you divide, you got to leave a space for it. So it's actually 4x squared plus 0x, then minus 1. Okay, so now we are ready to divide. So now you have to ask yourself, what multiplied by 4x squared give me 8x squared? So we know it's a 2. So here is just a 2. So this one times this one, I get 8x squared. This one times this one, I get 0x. This one times this one, I get minus 2. Let's do this one how? Easy. You just put a plus 0. Now I want to see what is my remainder. So I minus and put the bracket. Negative 1 minus 0. This is minus x. 0 minus minus 2. So this is plus 2. So this is a tricky question. Why? Because if you don't put the 0x and if you don't put the 0 here, okay, you have a lot of terms about how to minus, how to divide, then we get very confused, correct? Thanks for the rows. Okay, and over here, if you don't put the bracket here, you will think that this is minus x minus 2, which is wrong. It's supposed to be minus x plus 2 because minus minus. Okay, so now we are ready to put it into the mixed form. So that means 8x squared minus x over 4x squared minus 1 equals to the quotient 2 plus the remainder. Since it is minus x plus 2, I'm going to switch it to write it as 2 minus x over my this one. So it's 4x squared minus 1. So now this part here will be proper fraction. So you're going to do the partial fraction for this proper fraction. Okay, so we're going to write out here. So 2 minus x over 4x squared minus 1. Okay, take note that the denominator now is a quadratic, right? So common mistake is students, oh, okay, now I know this is actually case 3. Case 3 means that my numerator is ax plus b. Wrong. Every time when the denominator is quadratic, you must ask yourself whether, can I factorize it or not? Can I factorize it? So this one actually can simplify to become 2 minus x over 2x plus 1 and 2x minus 1. So you see, after I factorize, oh, so actually this partial fraction is case 1. So this will be equals to a over 2x plus 1 plus b over 2x minus 1. Okay? Understand? Now next, we got to combine this into a single fraction. So my common denominator is these two brackets. So this a is missing a 2x minus 1. This b is missing a 2x plus 1 over 2x plus 1 and 2x minus 1. Now your task is to compare this and this, because the denominator is the same. So we will write, okay, 2 minus x equals to a 2x minus 1 and 2x plus 1. Okay, this right hand side, okay, is not so difficult to rainbow. So we actually can use compare coefficient to solve my a and b. Or you want to sub suitable value, also can. Okay, for me is let's do the comparing coefficient since this one is easy to rainbow. So what I'm going to do is 2 minus x, keep this one rainbow. So 2ax minus a plus 2bx plus b. So by comparing, okay, I like to do this. So I write x. So if I want to compare the x, I can see that on the left hand side it is minus 1. On the right hand side, is 2a plus 2b. The bad news is I still cannot solve. Never mind. We go and compare the constant. So now we compare the constant. So constant on the left hand side is 2. On the right hand side, I get minus a and then plus b. So actually, I become two equations solving. I need to solve simultaneous. It's fine, still easy. So I let this b be the subject. B subject, it become 2 plus a. So I can just sub it here. So it become 2a plus 2 plus a equals to negative 1. Okay, I'm doing simultaneous. I'm doing simultaneous. This is like equation 1. This is like equation 2. So I'm subbing the equation 1 to equation 2. So I have 2a plus 4 plus 2a negative 1. So total I have 4a equals to minus 5. Minus 5 over 4, correct. So in the end, it's a very ugly a, no choice. A is equals to minus 5 over 4. And my b is equals to 2 plus negative 5 over 4, which I press calculator, 2 minus 5 over 4, I get 3/4. Okay, so you see, I'm done with my a and my b. And don't forget to complete it, because your task is to put this in partial fraction. So you will say, therefore, the 8x squared minus x over 4x squared minus 1. Don't forget your 2. Many students, after they solve the a and b, happily say that it's equals to these two fractions. But and then they forget that there's a 2 here. So it's supposed to be 2. My a is negative, right? So it's minus 5 over 4, 2x plus 1, plus 3 over 4, 2x minus 1. Yes. Yes, I'm right. So this is for the part 1 when we are doing partial fraction. Okay? So this question, good. First is the improper fraction. Common mistake, student never do the division, straight away you do the partial fraction. Second mistake, they straight away use ax plus b. They didn't split it to the two linear to split it this way. Some students argue with me, sure it's the same, it's the same. No, you will get the wrong, it's a different thing. It's totally different. Sometimes, even if you put it as ax plus b, you get very nice a and b there. So you thought that you will not get, there's no error. But it's already an error because you didn't do the long division. Okay? And then the next thing is this a and b is in fraction. Okay? So then after that, students might get confused. But don't worry, if you get fractions, you're not, then you just need to double check and see that you didn't make any mistake. And if you didn't make any mistake, then this is correct. Then the next mistake is student forget to pull back the 2. Okay, so this is one question which is very good to test your knowledge about partial fraction. So now, part 2. They said use your result in part 1 to find integration of this. So this is exactly the same as this. Exactly the same. So I can say, oh, if they ask me to integrate 8x squared minus x over 4x squared minus 1, it means that they also want me to integrate this. Because it's the same thing, So it means that I want to integrate this 2 minus 5 over 4 2x plus 1 plus 3 over 4 2x minus 1 dx. So integration 2 is very straightforward. Okay? And take note, this is to the power of negative 1. Every time you want to integrate to the power of negative 1, the only way is ln. Okay? So this becomes x minus 5 over 4 ln 2x plus 1. Don't forget to differentiate the inside and put it at the denominator. Plus 3/4 ln 2x minus 1 over 2. And this one, there's no limit, so you got to put plus c. So let's simplify. So 5 over 2 times 5 over 8. So this is x minus 5 over 8 ln 2x plus 1 half 3 over 8 plus 3 over 8 ln 2x minus 1 plus c. 3 over 8, and we are done. Oops, my bad. I make a mistake. Yes, Tara, you're right. I'm about to write that. Integration of 2 is 2x, not x. My bad. Yeah. Okay, integration of 2 is 2x, not x. So, not bad. You are observant. Okay? And we are done. Okay, so 6 marks. Okay, let's move on to the next question. Okay, again, area under the curve. Can you explain? Can you explain how you got 2 for part A at the top? Here, bracket after 2x plus 1. What is the Marco question? Okay, Kusan 1, Raghu already replied. Good. Okay, how about Marco? Bracket after 2x plus 1. Oh! Thanks. Wow! Marco, this one small thing you also notice, good. Okay, yes, he is right. I forgot to close back, Thank you. Okay? Yes, Kusan. So, Raghu already replied you. So, it means that you are supposed to do the long division. Yes, because I do the long division. What I did was, I asked myself, what multiplied by 4x squared give me 8x squared? So, it's actually times 2. Okay? Doing the long division part, because it's an improper fraction. Okay, let's continue to the next question. So, this one, they asked me to find the coordinate of A, B, and C. Not that tough, okay? Your coordinate geometry has to be very strong. Okay, you need to understand the basic of coordinate geometry. So you can see that A and B is the intersection point between the curve and the line. And this is not tough. Why? Because equation of the curve is given, equation of the line is given. What's the difference between proper and improper fraction? Okay, in algebraic fraction, in normal fractions of, I hope you know what is that. Proper fraction is like 3/4. Okay, 4 over 3 is improper fraction. It's like the head is bigger than the bottom. So we will have 1 whole 1/3. This kind is called improper fraction. This is called proper fraction. Okay, in algebraic expression, how do we know whether the is it a proper or improper fraction? This is I shall call it my numerator. My numerator if the degree is more than or equals to the denominator, then it is considered a improper. Okay, the degree of the numerator is greater or equals to the denominator, then it's considered improper. Then you will have to do the long division. So commonly is students know that when the degree is greater, they will know that it's improper. But they actually forget that actually when it is the same degree, for this case you see it's the same degree, x squared and x squared, it is still considered a improper. Yes, degree is the power of the x. Correct. Degree is the power of the highest. Ax squared minus x, the highest is x squared. So the degree is 2. Okay? Good. Let's continue. Where am I? Over here. Okay, let's continue to the next question. So we're going to do our simultaneous, okay? This question actually is not tough, but later part when we are doing the area, I tell you, the subbing value I will faint. But in this case, it is considered improper then because 8 divided by 4. Yes, 8 divided by 4. Correct. Okay, now let's take a look. So I want to solve A and B. I need to do simultaneous. So I want to make simultaneous. So this one is 9y, right? So I will say 5 over 2x minus 1, no problem, is equals to minus 10x plus 55 divided by 9. Just curious, are you from Singapore or are you doing from other country? We got our math A level on Tuesday. Good luck. Is it IGCSE or is it from Singapore? English doing GCSE, right? I'm also having IGCSE on Tuesday, but I take the Math B. I'm taking Math B. Yes. Maybe next year I take the pure math. Or A level is higher. A level is higher than the GCSE, is it? Okay. But if yours is higher, are you still tested on all this? This should be tested on lower, right? GCSE for 16 years old, A level for 18 years old. 18 years old still test this one? Isn't this shouldn't be tested under 16 years old? I haven't taken the exam yet. I will take next year, I think, the pure mathematics for GCSE. Okay, so this is like more on recap for you, is it? Okay, so now in England GCSE don't learn this stuff. In England GCSE don't learn this stuff. Oh, GCSE further pure math do this. Yes, I'm going to take the pure math paper next year. So I believe this will be inside lah. Okay, come. So now let's solve our simultaneous. So what I'm going to do is we can do cross multiply. So it will be minus 10x plus 55, 2x minus 1 equals to 45. So let's do our rainbow. So minus 20x squared plus 10x plus 110x minus 55 minus 45 equals to 0. So when I reduce, I have minus 20x squared plus 120x minus 100 equals to 0. So I'm going to divide by negative 20 to have a nicer equation. So I have x squared minus 6x plus 5 equals to 0. So let's factorize this. So it becomes x minus 5, x minus 1 equals to 0. X equals to 5 or x equals to 1. So with this, I know that here we always draw the vertical line down. So this is 1 and this is 5. Okay, we will need it later when we are trying to find the area. We will need that. Okay, so then let's continue. Because they want the coordinate, let's find out what's my y also. So my y, okay, I'm going to sub it into here. It's easier. So it will be 5 over 2, 5 minus 1, which I get 5 over 9. The other one is 5 over 2, 1 minus 1, which we will get 5. 1, sorry. Is it 1? No, 5, correct. So therefore, my A is 1, 5, and my B is 5, 5 over 9. Yes. So just now I write the x already. I also want to write my y because I might need it later. So I'm going to dot here. This A is 5. This B is 5 and 5, 9. Okay, so now next I need to find my C. C is here. C is on the line. And it's on the x-axis, that means I need to sub y equals to 0. So let's sub y equals to 0. So we will have 9, 0 equals to minus 10x plus 55. So my 10x equals to 55. X will be equals to 5.5. So therefore, C is 5.5, 0. So my C here is 5.5. Okay. So now we are ready to find the area of the shaded. So there's a lot of parts. So to find the shaded area, see here. I can take. Actually, I can take the triangle. I take the trapezium. Okay, I'm going to write here. Area of the shaded. Give me a moment. Wait, I got a very urgent message. Okay, sorry, I'm back. Okay, so area of the shaded, I have to take trapezium. See, I will have to take the area of the trapezium minus integration of under the curve. Okay, so it will be integration of the curve, which is 5, 2x minus 1 to the power of minus 1. Sweep from 5 to 1. Okay, so this portion, this is actually the area of the bigger shaded one. And I still have a smaller one. The smaller one, it will be a little bit tricky. I will have to take the area of the under the curve minus the triangle. So I have to take plus integration. Same thing, the 5, 2x minus 1 dx minus the triangle. Can see? See, because the curve is here. Area under the curve, I sweep from 5.5 to 5. 5.5 to 5. 5.5 to 5. Minus away the mini triangle. I'm going to put the right angle here. Then I will get the smaller shaded. Can? The trapezium actually is this one. This part. Because when we integrate, okay, see, because when we integrate 5 to 1, it is the unshaded, is the under the curve. So we need to take the trapezium minus the unshaded, then we will get the shaded. Agree? Okay. So let's proceed. So over here, trapezium, let's find my trapezium. So trapezium formula is half times sum of parallel side multiplied by the height. So my parallel side is this one. Okay, this is the parallel line. So here is one side which is 5. The smaller one is actually 5/9. So the trapezium is half 5 plus 5/9 multiplied by the height. The height is 5 minus 1, which is 4 units. Okay, minus. Okay, so now we're supposed to integrate this one. Integrate this one because it's -1, so it's actually long. Okay, the 5 I can put it outside. Okay, I shall put this. So it's 5 ln 2x minus 1 over, differentiate the inside, which is 2. And I'm supposed to sub in 5 and 1. Okay, so this is very tedious because there's quite a lot of portion. Then over here, I'm going to plus, same thing, 5 ln 2x minus 1 over 2. This time round, I'm supposed to sub in 5.5 and 5. Minus the triangle. Triangle is half times base times height. So let's take a look at what is the base and height. So the base is actually just 5.5 minus 5, so it's 0.5. The height is 5/9. So this is half times 5/9 times 0.5. Okay. So now we need to sub in our value and get. So this one, the area of the trapezium is actually 11/1/9. Okay. This one, it will be 5 half ln 9 minus half ln 1 plus 5. This one again, this is wait, it will be 1.1512 minus 1.0986 minus 5/36. Okay, anyway, just sub everything in. Okay, just press the calculator. Eventually, you will get 5.74215. Round off to 3SF, it will be 5.74 unit squared. Done. 3SF. Okay. Okay. So we are done with the 3SF is three significant figure. 3 significant figures. Okay, so this is how you do this question. Okay, so we are done for the day. So we have done 4 questions.